Hello, it's Carly McAvoy. I wanted to review a few things that you need to know as you finish the quarter. Evaluate an expression, solve for a variable, determine m and b, slope and y-intercept, and a brief explanation of variation. When you're asked to evaluate an expression, that means you're asked to substitute the value in for the variable. And remember, this is saying x squared. And if I wrote x squared out in longhand terms, I would write x times x. And so when you think about -3, people say, well, how do you know you're putting parentheses around it? Because what I'm actually saying is -3 times -3, right? That's -3 to the second power. So I always want to put parentheses around that. And then here I want to put parentheses because if I didn't, it could look like a subtraction problem. This is -5 times -3 and then plus 7. -3 times -3 is +9. -5 times -3 is +15. And so I have 9 plus 15 plus 7, which is 24, 31. You guys can check my addition on that one. So 31. When would you not put parentheses around it? Let's say I had this, x squared minus 4x, and I told you that x equals 3. Well, now I have a negative out front, but I have 3 squared. So see, I'm still putting the parentheses around the value, but that negative was not part of that. So in that case, -3 squared would be -9. And then you'd have -12 and -21. This is a different problem, so you have to look and see what problem you got. If you have x squared and your x value happens to be negative, that goes inside the parentheses. If you have -x squared and your x value is positive, then the negative is outside the parentheses. Okay, I just wanted to show you a basic solving equation. But what happens is when you put subscripts on things, people sometimes think that there's something different going on. It's just another way to write a variable. I want to solve for a subscript 1, which we just say a sub 1. So that we want to get this term by itself, so we're going to subtract c from both sides. That gives me b sub 1 minus c equals 3a sub 1. And then I want to get a sub 1 by itself because I'm solving for that. So I'm going to divide by 3. I'm just going to divide each one of these by 3. And that's going to give me b sub 1 over 3 minus c over 3 equals a sub 1. That's a perfectly great way to write that. Another way to write it, oops, I did exponent 1 when I meant subscript 1. I could also write a sub 1 equals b sub 1 minus c all over 3. That's if I didn't look at those separately but put those together. So either one of those is acceptable for an answer. This one or this one. Okay, then determine m and b for the following graphs. Well, m is the slope, that is the steepness of the line. And I don't want to determine the exact values here. I just want to say, is m greater than 0 or is m less than 0? And I want to ask the same thing for b. Is it greater than 0 or is it less than 0? That's what we're asking. Those are the questions that you're going to be asked. So when you see a line that rises from left to right, then you know that slope is positive because positive slopes rise and positive is greater than 0. So for this one, m is greater than 0. I don't know exactly what it is. I could figure it out. But what I'm just interested in is it positive or negative? It's positive because it's rising. Look at m here. Here it's falling. So here m is less than 0 because it's negative. This one's also falling from left to right. So m is less than 0. So either your slope is greater than 0 or less than 0. If it's equal to 0, then you would have a flat line. Okay, what about B? B is the Y-intercept, or in other words, where does it cross the Y-axis? Is it greater than 0 above the x-axis, or is it less than 0 and that's below the x-axis? Well, here our Y-intercept is right here, and that is definitely below or in the negative values. So B is negative, so it's less than 0. Here, B crosses positive because it's above the 0 point. So B is greater than 0. And here, B is here, again, that's negative because it's below the x-axis, so B is less than 0. Notice your slope and your y-intercept could both be negative, they could both be positive, or they could have one of each, okay? And then finally, a couple of things about proportions. If you say something varies directly, is directly proportional, that means that if x goes up, then y goes up. If x goes down, then y goes down. And then the formula for that is y equals kx. K is some constant that we have to figure out. And if you think about that in terms of everyday life, think about it as if you get paid. The amount of hours that you work is going to affect your pay. So your pay is directly proportional to the hours that you work. What's the constant in that situation? The constant is your hourly wage. So if you make $10 an hour, if you work 7 hours, you would say 7 times 10. Your constant is the thing that doesn't change. Here in that scenario that I just said, your hours going up would cause your pay to go up, but your hours going down would give you less pay. So that's a direct proportion. So what we do to solve this is we plug in x and y to find k, and we're always first given that x and y. So we say y is 10, we don't know k, but we know x is 1/2. So if I solve for k, I'm just going to multiply both sides by 2, and that's going to give me that k equals 20. I think sometimes they'll ask you to find k first and then find the other one. Now we know k, we're going to plug in k and the other given, which was 5 in this case, to find the unknown, which was y. So I go back to y equals kx. I don't know y, but I know k is 20, and I now know that x is 5, and that's going to tell me y is 100. So we found that by plugging into this very simple formula, y equals kx. This was direct proportion. If your proportion was inverse, that is like the number of roommates that you have makes your individual payment go down for rent, right? But the constant would be the amount of rent the landlord wants, regardless of whether you have 2 or 3 roommates. That's an inverse relationship, and you'd solve it the same way, but you would use y equals k over x. Okay, here's an example of a direct variation. The strength of a beam varies directly with the width. Let's say the strength is S. It varies directly with the width, so the K we don't know, but we know that the strength varies directly with the width. So it's the same basic formula that we saw before. Instead of X and Y, I'm using S and W. If the beam is 6 inches wide, it supports this many pounds. Remember the 2 steps you can see there, plug in the X and Y to find K. We don't have X and Y, but we can still plug in 3,276 pounds supported when you have a 6-inch width. So we're going to divide both sides by 6 to find out what our constant is. And that is 3,276 divided by 6, or 546. So the constant here is 546. I go back to that equation and I plug in what I know, and that is 546. And the width was given now as 4.5. Should it go down or up? Well, it's directly proportional. So if one goes down, the other goes down. All I have to do is take 546 times 4.5, and I get 2,457. And that's pounds. It supports 2,457 pounds. All right, have a great day.